Hi, everybody. We are working on Math Module 5, Lesson 19 today. In your Succeed book, it is page 209. This is a little bit different today because the whole point of today and tomorrow's lesson is to think about the different strategies and to explain your thinking. So I'm going to be asking you to pause a lot today to do some work and some thinking on your own, and then I will share with you my thinking on the problem. So we're going to go ahead and get started with this first problem. This is an addition problem. We need to focus on that. Which operation are we doing for each question? And here we are using addition. 340 plus 250. And I want you to pause for a moment and think about what strategy would you use. There's vertical form, there's totals below, there's the standard algorithm, the chip model, lots of different ways you could do it. Which one would you choose? For me, when I look at these, I can see just by thinking about the numbers, I can see I'm not going to need to compose. I'm not going to make a 10 with my ones. I'm not going to make 10 with my tens. So this is a much easier problem for me, and it makes sense just to do with the standard algorithm, the vertical form. Now, you could also possibly just do this in your head using your place value strategies, adding your hundreds, your tens, your ones. So I'm going to go ahead and write 340 plus 250. It's pretty straightforward. Like I said, I can't make 10 ones. I can't make 10 tens. This is going to be pretty straight up addition. So 0 plus 0 is 0. 4 plus 5 is 9. 3 plus 2 is 5. So I'm going to make sure I write that up here. And then here comes the focus for today. Why? Explain why I chose that strategy. Now, whatever your strategy was, mental math, vertical form, chip model, you need to say why. Why did you choose that? There's nothing wrong with the chip model. If that is where you are most comfortable, you should use that. You should just be aware that it's not always the most efficient, right? The fastest, easiest way to find your answer. The chip model is just not always going to be that. But for me, because I didn't need to compose groups of 10, I thought vertical form would be quick and easy. Now, you do not, sorry, that ran off the edge there. You do not need to write the same thinking that I had, especially if you used a different strategy. There is no need for you to use the same strategy that I did, and therefore your explanation might not be the same. Think about how we talked about it in class. We are working to get the same answer. We do not need to get there the same way. So take a minute to pause if you need to finish up your explanation, and I'm going to move on to the next problem. So the second problem here, B, 490, again, we're doing addition, 490 plus 350. Now I can see I'm not going to get 10 ones, but I can see that I'm going to have to compose in my tens, right? Think about it. What strategy would you use? For me, and I think I've told you this before, totals below is the way I actually think about this kind of math in my head. I have a very difficult time composing and holding on to all of those groups in my head. So when I do this, I think of it as my hundreds and my tens separately and then put them together, which is what totals below really is. You can start on either end. You can start with your hundreds or your ones. Doesn't matter. You could even start with your tens, but that seems really complicated. 0 plus 0 is 0. 9 tens plus 5 tens is 9 tens, 10, 11, 12, 13, 14. So 14 tens, it's not going to be 14, it's going to be 14 tens, 140. And then I need to add my hundreds. I have 400 plus 300, which is going to be 700. And then I add those together. Now again, you might have used the arrow way. You might have used, this might have been a good time to decompose and take 10 away from this one. That would have been a nice way to do it. Let's look at that, see if any of you did that. So we have 490 plus 350. If I just use a number bond here to decompose, I'm going to take, I want to get this one to the next 100 so that I can have zeros in both tens and ones. How much is this going to need to get it to the next 100? I've got 9 tens. I'm going to need one more 10 to make that 10 tens. So if I take 10 out of 5 tens, I'm going to be left with 4 tens. And then I'm going to put these together, and that's going to be 500 plus what's left over here, 340. That's a super easy addition problem. Adding with zeros, I'm going to have 840, which is what we got using the other strategy. This might be an easier way to do it than totals below. Again, like I said, you need to find the strategy that you are most comfortable with. So for me, if I'm thinking of totals below, it is easier to use totals below than to compose a new group of 10 tens, in my opinion. Now, if in fact you used the decomposing to get to a friendlier number, like I showed you on the whiteboard, that would be a different explanation, right? If you use the chip model, that's a different explanation. If you use the arrow form, all of those are different strategies. And if you used a different strategy than I did, your explanation is not necessarily going to be the same. I want you to think about how you solved it and why you chose that way. Go ahead and finish up your explanation and then restart the video when you're ready to move on. All right, I'm going to go on to C, the last one on this side, and still we have an addition sentence. We have 519 plus 342 goodness. Doesn't look like a super easy problem to solve. None of them are really close to friendlier numbers. We could take one away and make it 520, but that's not that much friendlier. I can see that I'm probably going to need to compose a new group of 10 ones to make a group of 10. So I'm either going to need to use totals below or maybe the chip model so that I can see all of those things I'm doing. If I'm using the chip model, I'm actually going to go ahead and show my work in vertical form. So I'm going to do 519 plus 342 out here. And then in here, I'm going to draw my chip model. Because we're using chips instead of disks, we do need to label those. You can do it HTO, hundreds, tens, and ones, or you can write the numbers. And because we are taking two parts and putting them together, we need to model both of these numbers in our chip model. So starting with 519, I'm going to need 1, 2, 3, 4, 5 hundreds. There's 110 and 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my second number, 342. 3 in the hundreds place, 4 in the tens place, and just 2 ones. So I'm going to start with my ones. Can I make a group of 10 if I have 9 and 2? I can, because 9 only needs one more to make 10. So very carefully, make sure you can still see that one that's left over there. I'm circling my group of 10, drawing an arrow, and putting my new group of 10 there in the tens place. I need to make sure my vertical form matches. So here I have 9 plus 2. 9 and 2 is 10, 1. So I'm going to put 1 that's left there, and then my new group of 10 there. So this looks the same. I have 1 plus 4 plus 1, 1 plus 4 plus 1, and that is 6. I couldn't make a group of 10 here, so I do not need to make a new 100. I'm just going to add now my hundreds. I have 5 hundreds plus 3 hundreds. 5 plus 3 is 800. And then I'm going to take that sum and put it up here so that I've completed my equation. Now, you might have used a different way. The arrow way, totals below, whatever you chose to use is fine. You may have just used the standard algorithm, and that's fine. We're working to choose the strategy that works best for us and to be able to explain why we chose it. Now, to me, this isn't close. To a friendlier number. So just decomposing and moving numbers around didn't make sense. I could have done totals below, but I knew I was going to need to compose. And I knew I needed to compose. Ooh, you can't see that at all. I knew I needed to compose a group of 10 ones. Now for me, that meant the chip model was going to be easier or totals below. Entirely up to you though. So please make sure that your explanation matches whichever strategy you chose. You can go ahead and pause. I'm going to move on to the next page, going to 210. we're doing the same thing. We have 610 plus something equals 784. Well, it's kind of the same thing. We're looking here. Do we have two parts that make up a whole? No, we have a whole and one part. This plus something equals this. Now, when we have this, we can either count up to this next number or subtract. When we are missing a part, that's what we have to do. We are either counting up or subtracting. Now, subtracting wouldn't be difficult. These numbers are all larger than those numbers. Counting on always makes me think of the arrow way. But I think the standard form of subtraction will be easy because I'm not going to need to decompose. The numbers in my whole are all bigger than the numbers in my part. So 784 minus 610. I can take 0 from 4. 4 minus 0 is 4. I can take 1 from 8. 8 minus 1 is 7. I can take 6 from 7. 7 minus 6 is 1. Now, I can check my answer by adding those two parts together and making sure I've done it correctly. 0 plus 4 is 4. 1 plus 7 is 8. 6 plus 1 is 7. And if I add my two parts together and get the whole, then I have completed my work correctly. So I'm going to go ahead and put the other part, 174, in the equation. And I'm going to explain what I did. Now, you might have used the arrow way. The arrow way is a perfectly acceptable way to solve this problem. When we're missing a part, remember, we either count up or subtract. Those are our choices. So my explanation, I used the vertical form because I knew I didn't need to decompose. If any of these numbers were smaller than the numbers in the part, then definitely I would have done the arrow way. But because it wasn't going to need to decompose, just straight up vertical form is pretty easy. Go ahead and finish yours up. I'm moving on to E. We're almost done. We have two left. Looking at E, it says 700 minus 456. Now, same thing. Please remember, same thing. We can, when we are subtracting, we could always switch it around and use the arrow way to count up to the whole to find that missing part. But I also know that when I have 0, 0, compensation is the way to go. So I'm going to just draw my tape diagram. And this is 700. And this is 456. But if I just take one away from each of those, that is a much easier problem to solve. If I take one away from 700, I'm going to get 699. One away from 456, I'm going to have 455. So now I'm just subtracting 699 minus 455. 9 minus 5 is 4. Same thing. 6 minus 4 is 2. Is that the way you solved it? Did you use the standard algorithm in a chip model? Did you do the arrow way? As long as you also got 244, then it doesn't really matter which way you used. Although this is a much simpler problem than 700 minus 456. We have to take 100 to make more 10s and then a 10 to make more 1s. Much harder to do and a lot of work in your chip model. This is much faster. Compensation. Not is, I'm going to say makes a much easier problem to solve. And again, if you used a different way, you need to say why you did. You do not need to change your answer to look like mine. You used what you used for a reason. Just say why. If you're using what you're most comfortable with, that's all that really matters. All right, last problem. 904 minus 395. Take a minute, think about it. How would you solve this problem? Pause and do it your way, and then push play to see how I solved it. There are a lot of different ways to do this problem, but for me, 904 minus 395 looks to me like the easiest way is again going to be compensation. I'm just going to make an easier problem. Because if I just add 5 to 395, I get 400. I don't want all those zeros in my whole, but zeros in the part make a much easier subtraction problem. So here I just need to add 5 to this one as well, which is going to give me 909. And now I have this much easier problem. 909 minus 400. I'm not taking anything away from my 1s or my 10s, so those numbers are going to stay the same. I am only subtracting from the hundreds. So 900 minus 400 is 500. And these are going to stay the same. My answer is 509. And my explanation is the same. Compensation makes a much easier problem to solve. Again, you could have used the standard algorithm. You could have used the chip model. You could have used the arrow way, either going backwards or forwards. But all of those are a little bit harder than just making an easier problem. Compensation is an excellent strategy sometimes. Compensation makes an easier problem to solve. We're going to be doing a lot the same in lesson 20, so I'll see you back tomorrow.